Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. Today, I will discuss one of the complex topic of internal combustion engine. So, in this lecture, I will discuss basically main components of IC engine, then comparison between 2-stroke and 4-stroke engine, then comparison between SI and CI engines, and in last I will discuss what is Otto cycle and diesel cycle. So basically, first of all, I will discuss what are the main components of any internal combustion engine. So the first component, this is the schematic representation of 4-stroke diesel or petrol engine. Basically, in petrol engine there is spark plug, whereas in diesel engine there is a fuel injector. Okay, so this schematic diagram can be for diesel as well as petrol, but keep in mind, in petrol there is spark plug and in diesel there is fuel injector. Okay, so the first component is inlet valve. What is inlet valve? This is inlet valve. This one is called inlet valve. It allows the air fuel mixture in petrol engines, whereas only air in diesel engines to enter the combustion chamber. Then what is exhaust valve? This one is exhaust valve. It releases the burnt gases from the combustion chamber into the exhaust manifold. Then third component is spark plug in the case of SI or petrol engine. So basically, spark plug produces a spark to ignite the air fuel mixture in petrol engines. It is not used in diesel engine. The spark plugs only used in SI engine to generate the spark. With the help of this spark, combustion take place. Then next one is fuel injector. This one is fuel injector. What is fuel injector? It injects a fine spray of fuel directly into the combustion chamber. It is only used in diesel engines, not used in petrol. Then what is inlet manifold? This one is inlet manifold, this green one. What is inlet manifold? It is a passage that delivers the air fuel mixture or air to the inlet valve from the carburetor or air filter. So this is the inlet manifold. Then what is exhaust manifold? This one, red one. So basically, exhaust manifold collect the exhaust gases from the exhaust valve and directs them to the exhaust pipe. Then next one is cylinder. What is cylinder? This one is this one is called cylinder. Basically, the chamber where the piston moves up and down and combustion takes place. This is called cylinder. Then what is piston? This one is called piston. What is piston? A reciprocating component that compresses the charge and transmit the force from combustion to the crankshaft via connecting rod. So this one is connecting rod and this is crankshaft. It can transfer force from combustion to the crankshaft via connecting rod. Then third one is gudgeon pin. Then another one is gudgeon pin, yeah, wrist pin. What is this? This connects the piston to the connecting rod and allows relative motion between them. Then next one is connecting rod. What is connecting rod? This one. It connects the piston to the crank and converts reciprocating motion into rotary motion. So this convert reciprocating motion of the piston to the rotary motion of the crankshaft. Then another one is cylinder block. What is cylinder block? This block is called cylinder block. What is cylinder block? The main structure of the engine that houses the cylinder. It may be one, yeah, more than one, and supports the other engine parts also. Then what is cylinder head? This one is called cylinder head. So basically, it sits atop the cylinder block, houses the valves, spark plug, fuel injector, and often part of the cooling system. Forms the combustion chamber top. This is called cylinder head. Then next one is called crank. What is crank? This one is crank. It converts reciprocating motion from the piston into rotational motion for the crankshaft. Then what is crank pin? This one is called crank pin. An offset part of the crankshaft where the connecting rod is attached. Okay. Then crankshaft. This one is crankshaft. What is crankshaft? Transmit the rotary motion to the flywheel and eventually to the drive. This is called crankshaft. Function of crankshaft. Then next one is carburetor. What is carburetor? Basically, it is used in SI engine only. So in carburetor, it mixes air and fuel in the correct ratio for combustion in petrol engines only. Then what is injection pump? It is used in diesel engine. So pressurized and delivers the precise amount of diesel fuel to the engine cylinder in diesel engines only. Then what is flywheel? It stores the rotational energy to smooth out engine pulses and maintain constant speed. Then what is the function of camshaft? Opens and closes the engine's intake and exhaust valves at the correct time. Then what is timing mechanism? It synchronizes the movement of the crankshaft and camshaft to ensure proper valve operation and ignition time. So these are the main components of any internal combustion engines and their functions. Now I will discuss what is comparison between SI and CI engine. SI means spark ignition, CI means compression ignition. SI are also known as petrol, whereas CI also known as diesel engine. So this is point term comparison. Then is SI and CI. According to basic working cycle, in SI engine it uses Otto cycle and CI engine works on diesel cycle. Fuel used, according to fuel used, the SI engine uses petrol or gasoline, whereas CI engine uses diesel only. Ignition method, SI engine uses spark plug, whereas in diesel high compression and fuel injection. By the help of high compression and fuel injection, combustion takes place in CI engine. According to compression ratio, SI engine, the compression ratio of SI engine are low, 6:1 to 10:1, whereas in CI engine it is high, 16:1 to 22:1. Then what is, according to thermal efficiency, what is thermal efficiency? It is the ratio of work output divided by heat input. So according to thermal efficiency, SI engine thermal efficiency are lower, whereas CI engine thermal efficiency are higher. According to based on cost, SI engine are less expensive, whereas CI engine are more expensive. According to maintenance, the maintenance of SI engine are easier, whereas maintenance of CI engine are more complex. Then according to noise and vibration, in SI engine are produce less noise and vibration, whereas in CI engine more noise and vibrations are produced. Power output, SI engine produces higher RPM, whereas CI engine produces higher torque. Or according to applications, SI engines are used in cars, bikes, small vehicles, etc. Whereas in CI engine, these are used in trucks, buses and generator. These are the classification of And these are the comparison between SI and CI. Now, I will discuss comparison between 2-stroke and 4-stroke engine. So, first of all, what is 2-stroke engine and what is 4-stroke engine? In 2-stroke engine, one complete cycle is completed in 2 stroke of the piston or 1 revolution of the crankshaft, whereas in 4-stroke engine, one complete cycle completed in 4 stroke of the piston or 2 revolution of the crankshaft. So, according to power stroke, 4-stroke engine, in 4-stroke engine, once every 2 revolution, we got 1 power stroke in every 2 revolutions, whereas in 2-stroke engine, 1 power stroke achieved once every revolution. Then efficiency, 4-stroke engine are more fuel efficient and 2-stroke engines are less efficient. Then lubrication, in 4-stroke engine uses separate lubrication, whereas 2-stroke engine lubricant mixed with fuel. Mechanical complexity, in 4-stroke engine, these are more complex because it has valves and camshaft, but in 2-stroke engine, mechanical complexity is simpler because it uses ports instead of valves. Then wear and tear. In 4-stroke engine, less wear and tear is less due to fewer power stroke, whereas in 2-stroke engine more due to frequent stroke. Then fuel combustion, it consumes less, but in 2-stroke engines, fuel consumption is more. Emissions, it in 4-stroke engine produces less emission, whereas 2-stroke engine produces more in complete combustion, more emissions. Then according to application, 4-stroke engines are used in cars, motorcycles and generators, whereas 2-stroke engines are used in mopeds, chainsaw and small engines. So these are the comparison between 4-stroke and 2-stroke engine. Now I will discuss what is Otto cycle. So basically Otto cycle is the ideal, ideal means ideal thermodynamic cycle for spark ignition petrol engines. In other words, we can say that all the petrol engines, it may be 2-stroke or 4-stroke, works on this Otto cycle. Otto cycle consists of 4 processes. Process 1 to 2 is isentropic compression. Isentropic compression means air fuel mixture is compressed adiabatically. Adiabatically means at constant entropy. Then process 2 to 3, constant volume heat addition. Here mixture ignites increasing pressure at constant volume. Then process 3 to 4, isentropic expansion means high pressure gases expanded doing work at constant entropy. Then process 4 to 1, last process, constant volume heat rejection. Here exhaust gases are expelled at constant volume. So these are the 4 processes of Otto cycle. Then this is the PV and TS diagram of Otto cycle. Here in this diagram, 1 to 2 is isentropic compression of air fuel mixture. Then process 2 to 3, constant volume heat addition. Then process 3 to 4, isentropic expansion. Then process 4 to 1, constant volume heat rejection. Similarly in TS diagram, this is process 1 to 2, 2 to 3, 3 to 4 and 4 to 2. If we write the efficiency of Otto cycle, so the efficiency of Otto cycle is work output divided by heat input. Here work output is this. A heat input is this Q in. Also, we can write work output is Q in minus Q out divided by Q in. The efficiency of Otto. By using this formula, we can calculate the thermal efficiency of Otto cycle. Now, I will discuss what is diesel cycle. So, basically, the diesel cycle is the ideal cycle for compression ignition or diesel engines. In other words, we can say that all the diesel engines, either it is 2-stroke or 4-stroke, works on diesel cycle. Diesel cycle also consists of 4 processes. Process 1 to 2 is isentropic compression, means air alone is compressed adiabatically. Process 2 to 3 is constant pressure heat addition, means fuel is injected and burns at constant pressure. Then process 3 to 4, isentropic expansion, means combustion gases expand doing work at constant entropy. And last process 4 to 1 is constant volume heat rejection. Here heat is rejected at constant volume. These are the processes of diesel cycle. Now, I will discuss its PV and TS diagram. So, this is the PV diagram and this is the TS diagram of diesel cycle. Here process 1 to 2 यानी कि isentropic compression, then constant pressure heat addition, then isentropic expansion, then constant volume heat rejection. Similarly, in TS diagram 1 to 2, 2 to 3, 3 to 4 and 4 to 5. So, the only difference between Otto and diesel cycle is in Otto cycle heat addition take place at constant volume, whereas in diesel cycle heat addition take place at constant pressure, and rest processes are same for diesel and Otto. So, this is all about for this lecture.